Quick Facts with Franklin. I hope you learned something. Love you. Bye. The anglerfish lives where sunlight never reaches, forcing it to invent its own sun. It hangs motionless, waiting with a glowing bulb right on its head. This isn't magic. It is a biological trap designed to trick hungry prey into walking straight into a mouth full of teeth. In the deep ocean, light means food, and this fish owns the only flashlight in miles. Here is how the trick works. That glowing bulb is called an esca, and it houses a colony of bioluminescent bacteria. These tiny microbes create light through a chemical reaction, acting like a living battery. The fish provides food and shelter, while the bacteria provide the glow. It is a perfect partnership where two species share resources to survive in the pitch black. Engineers are now copying this biological trick to build better deep-sea sensors. By mimicking the bacteria's energy efficiency, scientists create lights that run for years without batteries in extreme pressure zones. This natural design helps us explore the ocean floor and develop medical imaging tools that require less power but deliver brighter results. Here is a mind-blowing detail. Male anglerfish are tiny and often fuse permanently with the female to become a parasitic sperm sac. They lose their eyes and organs just to provide genetic material while she hunts. This extreme adaptation ensures reproduction in an ocean where finding a mate is nearly impossible. To learn more about the anglerfish's deep-sea lore, read about marine biology, or watch documentaries about these deep-sea wonders. Visit your local museum to see if there are anglerfish exhibits. These deep-sea fish are an important part of their ecosystem. The gecko feet adhesion phenomenon is a biological miracle that defies everything you think you know about sticking things together. Watch a lizard sprint up a glass ceiling without any glue or sticky residue. It looks like magic, but the secret lies in millions of tiny hairs called septa. These microscopic structures create an invisible force that holds the animal to smooth surfaces. Scientists call this van der Waals force, and it works on almost any material. You might think friction is needed, but these feet actually work best when they are perfectly clean and dry. This biological miracle allows them to scale walls faster than a human can climb a ladder. The real question is how such small hairs generate enough power to hold the entire body weight of the gecko against gravity. Here is how the magic actually works. Each tiny hair on the gecko foot splits into hundreds of even smaller tips called spatulae. These nanotubes are so small, they get incredibly close to the surface atoms of whatever the lizard touches. When the distance gets that short, weak electrical forces snap together to create a strong bond. Think of it like billions of microscopic magnets sticking to a fridge door, but without any actual metal involved. The gecko controls this grip by simply changing the angle of its toes. Peeling back the foot breaks the connection instantly, making movement frictionless and effortless. This mechanism allows them to stick to smooth glass or rough brick with equal ease, using pure physics instead of sticky goo. Engineers are now copying this biological trick to build the next generation of climbing robots. By mimicking the gecko's nanotube structure, they have created synthetic tape that sticks to anything without leaving residue. This technology could allow rescue bots to scale crumbling buildings or let astronauts walk on smooth space station walls with zero risk of slipping. In nature, this adaptation means geckos can hunt insects in places predators cannot reach, giving them a massive survival advantage. The same force that keeps a lizard safe from falling also inspires new medical adhesives for delicate surgeries. We are moving closer to a world where sticky pads replace glue and screws entirely. Here is a fact that blows minds. A single square centimeter of gecko skin can hold the weight of 3 full-grown humans if all set a stick at once. This means the potential adhesion force is far stronger than the animal actually needs for its size. The gecko only uses a fraction of this power to move, saving energy while maintaining total control over its grip. It also works in a vacuum, proving that air or humidity has nothing to do with it. These forces are purely electrostatic and operate at the atomic level where quantum mechanics takes over. Understanding this could revolutionize how we handle heavy objects in zero-gravity environments. To learn more about gecko feet adhesion, read about biomimicry. Nature has some really fascinating tricks. Minnesota holds the title for having more lakes than any other nation on Earth, creating a freshwater paradise that stretches endlessly across the landscape. The capital city of St. Paul buzzes with the unique blend of historic charm and modern energy, setting the stage for true northern adventures. You will find it legal to wear a clown costume in public without a permit, while enjoying the state's famous native wild rice, which offers incredible value and nutrients. Travelers can drive from the bustling Twin Cities to the frozen peaks of the Boundary Waters in just a few hours to experience two completely different worlds. This land became the 32nd state in 1858, officially joining the Union with a promise of natural wonder that still resonates today. Visit the North Star State, and you might catch a glimpse of the beautiful Aurora Borealis. The common loon looks like a sleek black and white ninja. As the official Minnesota state bird, it acts like a dramatic opera singer, echoing across quiet waters. Males display sharp, striking patterns, while females blend seamlessly into the reeds to protect their precious nests. Minnesota residents know this bird well, as it dominates local lakes during summer months and returns every spring to claim its favorite feeding spots. These birds possess an incredible ability to dive deep underwater for minutes at a time. Their powerful wings act like flippers, allowing them to chase fish. Spotting this majestic silhouette against the dawn sky is the ultimate proof that you have experienced Minnesota. The eyelid blinking reflex happens 15 times every minute, yet you rarely notice it. Most think blinking is just a sleepy habit, but the reality is complex. Every time your lid snaps shut, it spreads a microscopic three-layer shield across your cornea that acts like high-tech aerospace lubrication. This isn't just water. It's a fluid film designed to protect your sensitive organ from dust and wind without you ever thinking about it. This miracle relies on a precise three-layer sandwich structure. Your eyelid spreads during every blink. The bottom layer is mucin, a sticky gel that acts like Velcro to hold the tears onto your eye. The middle layer is watery serum that washes away dust and bacteria. Finally, the top lipid layer is an oily shield that prevents evaporation, locking everything in place so your eyes stay wet for hours without constant watering. Engineers are now recreating this biological trick to create self-lubricating lenses for contact wearers that never dry out. This natural system prevents friction burns on the cornea, allowing you to read tiny text or drive at night without pain. In nature, animals like sharks use similar lipid layers to maintain clear vision underwater while hunting. Human tech is finally catching up to millions of years of evolutionary perfection to solve our own eye health crises. Here is the mind-blowing part. Your tears contain an enzyme called lysozyme that literally bursts open bacterial cell walls on contact. It acts as a microscopic army, destroying threats before they can even land on your cornea. This means every single blink is also a sterilization event, keeping your most sensitive organ free from infection without you needing to do anything at all. To learn more about eyelid blinking and tear film, read about ophthalmology. Next time you feel your eyes dry out, remember that it is Mother Nature telling you to talk less, blink more. I hope you learned something. If not, let's watch again. Love you. Bye.